In today's lesson, we're going to be extending the domain of trig ratios using the unit circle. So normally with trig ratios, what we've learned so far, they work with right triangles. So normally in a right triangle, we do not care about the 90-degree angle. We can look at the top angle or the bottom angle. Both of these angles are acute. So every time we're using sine, cosine, tangent, we're always looking at an acute angle. Well, what we're interested in doing is extending that domain to all real numbers. So I should be able to find the sine of 100 degrees or negative 100 degrees or a million degrees. I should still be able to find the sine, cosine, tangent. Up till now, it always had to be between 0 and 90. All right, so the angle being positive or negative always is going to signify direction, even if the number system, positive versus negative, is just two different directions. So we have to understand where the starting point would be, as well as which direction we should rotate. So for 0 degrees, it would be on the x-axis. So 0 degrees is marked here. And then it's a positive angle if it's going counterclockwise. So if it's going this direction, that's going to be positive. Now the reason they decided to make that the positive direction is that's the order we go through the quadrant. So we wanted to start with quadrant 1, then go to quadrant 2, then go to quadrant 3, and end in quadrant 4. So if you go the negative direction, it would be the reverse of that. And so negative would be going clockwise. All right, so negative is clockwise. And positive is counterclockwise. All right, so as I'm going around this circle, in that first quadrant, it's going to be similar to the diagrams we've already done. So I'm going to go ahead and clear that. Hopefully you had enough time to write that down. So negatives clockwise, positives counterclockwise. All right, so I've already marked off special points around the circle. Now it's called the unit circle because the length of the radius is 1, so 1 unit. All right, now this is a 30-degree angle. And previously we talked about a 30, 60, 90 triangle. So we know how to find the sine or cosine of a 30-degree angle, as well as the tangent, cotangent. We did that in the previous lesson. All right, so if I'm trying to find the coordinates of this point here, well, I would need to know this y as well as the length of x. All right, and I should be able to do that because I have an angle on one side, so I should be able to use trig ratios. So if I was trying to find the length of x, well, that would be the adjacent side, and the only other side length I know is the hypotenuse, so I would use cosine. So I could say the cosine of 30 degrees is equal to x over 1. All right, which would just be x. So x is, the length of x is just the cosine of 30 degrees. Similarly, if I wanted to find y, well, that's opposite of hypotenuse is sine. So the sine of 30 degrees is equal to y over 1. So y is equal to sine 30. All right, if I continued and I went to the next point, this would be a 45-degree angle. All right, and I wanted to find, again, the x and the y. Still to find that side, for y, it would still be the sine, but it would be sine of 45 degrees. And then for x, it would also be cosine. Right, so that's going to always hold true, where if you're finding the horizontal distance x, that's going to be using cosine. And if you're finding the vertical distance y, that was going to be sine. All right, so that's important. So for whatever angle, so for whatever angle, we'll call that theta. Right, theta will be the label of our angle. So it's important to know that the length of x is equal to the cosine of theta. All right, and the length of y is equal to the sine of theta. All right, so as we're going around, let's see, as we fill these in, we'll use the line tool. All right, this is 30 degrees. Here's 60 degrees, or 45 degrees, excuse me, and here's 60 degrees. All right, and we learned about those distances on the previous line, so we would use the sine and cosine of 30, 45, and 60. What's interesting also is that we can actually find the sine and cosine of 90 degrees now knowing what it does with the coordinates. Right, because the coordinates of those four quadrant angles would be 0, 1, negative 1, 0, 0, negative 1, and 1, 0. Right, and if x is cosine, that means the cosine of 0 degrees is 1. Right, and the sine of 0 degrees would be 0. All right, so this is 30 degrees, 45, and 60. And those were the only three angles we knew exact values of. All right, we're now able to extend that to, we know the exact values for 0 degrees, at least right now for sine and cosine, as well as this would be 90 degrees. Now we want to have a 60-degree angle, but in the second quadrant, right? So this is 60 degrees. Well, if that's 60 degrees, that means that the distance between that side and the y-axis would be 30 degrees. Similarly, this is 30 degrees, which means that this angle would be 120. All right, that's an 120-degree angle. All right. Also, there's 15 degrees between 60 and 45 and 45 and 30. So I'm going to go back to the line tool. This means that this would be 120 degrees, and then I can go up by 15s. So 135 and 150. Right, a straight line's 180, because I would add another 30, so that's 180 degrees. Right, and then this is a 30-degree difference right here. So from the 180, this marking would be 210. Then I can add the 15s. This would be 225, 240 degrees, 270 down at the bottom. This would be 300 because I add 30. And I can add the 15s, 315 and 330. All right, and then I would end at 360. If I kept going around, then that would be 390, 405, 420. So you can even see that since this is a circle, after you complete a full circle, so anything over 360, there's an equivalent angle that's between 0 and 360. Similarly, if I went in the negative direction, I'm going, clockwise, I should be able to find an angle that's equivalent to that between 0 and 360. All right, so that's allows us to extend from 0 to 90, which is that first quadrant, into every other quadrant. All right, so the other special angles that we could find now, so we started with 30 degrees, 45 degrees, and 60 degrees. Now using the unit circle, we're able to now define 0 degrees and find the sine cosine. 90 degrees, 120, this was 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360, which is the equivalent of 0 degrees. All right, so 0 degrees is the same thing as 360. All right, well, that'd be 360. And then it would just it would continue from there. All right, so these are now more angles that we know, and it's because it's going to be the the same as the first quadrant, but now we have to deal with, the rules of the quadrants of knowing negative, positive, negative, negative, positive, negative. Right, so this is now going to extend to more numbers, and we'll see in another lesson of finding those exact coordinates of those points using what we knew how to find the sine and cosine of 30 degrees, 45 degrees, and 60 degrees.